Okay, so here in this video, we're going to revisit taking derivatives, but also involving derivatives of multiple representations. And here's an example that's located on page 12. So we got to take into account that we've got this function h defined by this nice polynomial quadratic, 3x squared minus 4x plus 1. And I know that it's derivative already by the power rule, h prime of x equals 6x minus 4. And the derivative of g is that quadratic as well, but the derivative would be negative 2x. And now I'm given down here this graph of f. So what would be the derivative of f, say, at 4? So the derivative of f at 4 is equivalent to the slope of the tangent at 4. So here's my graph of f again, and here's the x value 4. I just need to figure out or approximate its slope at 4. Well, it's a straight line, and the slope of a line we know never changes. So if I count my blocks, I am going up how many units? 2, 4. And then I'm going left 2, so that's negative 2. So my slope of f at positive 4 is minus 2. What would be my slope, say, at 1? Well, here's when x is 1. Here's my point. And this is the line that contains 1. And its slope is up 2, up 4 total, sorry. And the right 2, so that'd be positive 2. So the slope along any point from here to here is minus 2, as we said. This would be positive 2 in that direction. And any point from here to here, its slope would be up 2 units, right 2, or positive 1. And any point along this segment would be minus 1. So the point being is the derivative of a point, the derivative of f, say at 4, is equivalent to the slope of the tangent at 4, which just means you have to count your rise over run, if you will, or how many units you move up or down, then right or left. So number 5, I want the derivative of k at 4. So I'm going to do my product rule. So k prime of x equals the first, f of x, times the derivative of the second, which is g prime, plus the second, which is g, times the derivative of f, which is f prime. Now I'm going to sub in the 4 and get that f at 4 times g prime at 4 plus g at 4 times f prime at 4. Well, f at 4 is going to be the y value from the graph. It's not a derivative value. And I could clearly see that when x is 4, y is 0. Now, g prime at 4, even though that value is going to be 0 there in the end, g prime at 4 would be found by replacing x with 4, and I would get negative 8. G at 4 means I've got to replace x with 4, and 1 minus 16 would be negative 15. It's the y value at g at 4. And f prime at 4, which we had just found here, the slope of the tangent of f at 4 is minus 2. And that's just 0 plus 30 is 30. In number 6, the derivative would be k prime of x is a quotient rule. It's the bottom function g times the derivative of the top, which is f prime, minus the top times the derivative of the bottom, all over the bottom squared. And now I'm going to sub in my value of 3. I'm going to be a little lazy here. I'm just going to, kind of cross out all these x's and put a 3. But I definitely have to cross out all the x's. So what's g at 3? I got to go here. And 1 minus 9 is minus 8. So I'll keep track of that pretty nicely. F prime at 3 is the slope of the tangent of f at 3. Well, 3 is still the point contained on this line, and that slope has not changed. So that would be minus 2. Now this part is f at 3, and this gets a little trickier, and this is very common on the exam. F at 3 is some y value off this line. I don't know what it is exactly, and you can't say, well, it looks to be maybe 2. You can never say that the value from a graph looks to be. You have to find the equation of the line. So I know that this line has a slope of negative 2. And so that's my mx plus b there. So I guess what I'm going to do is, I know an easy point here is 4, 0, and I know my slope is minus 2. So I'm going to do y minus 0 equals negative 2 times x minus 4. I'm just going to quickly do a point slope form. And this is the equation of that line. So therefore, f at 3 is found by replacing x with 3. That's negative 6 plus 8, which is 2. So f at 3 is the y value. It's got to come from the graph. But the issue is I had to actually find the equation of the line first, then followed by that. And what's g prime at 3? Well, the derivative is here, and negative 2 times 3 would be negative 6. And this is g at 3 squared. So g at 3 is 1 minus 9, which is minus 8 quantity squared. And that's going to give me, by the order of operations, 16 plus 12 over 64. And you can clean it up from there. In number 7, the derivative of k would be k prime of x equals 2 times f prime of x minus 3 times g prime of x plus 4 times h prime of x. No product rule. Constants just come along for the ride. So I need k prime at negative 1. So I'm just going to replace x with negative 1. So I need the graph of f, take its slope at negative 1. And negative 1 is here. I don't need to know that y value. I just need to know the slope of the line. So that slope of the tangent of f at negative 1 is minus 1. Now g prime at negative 1 will come from g prime, which is here. So now replace x with negative 1 times negative 2 is positive 2. And then h prime at negative 1, well, here's h prime. Replace x with negative 1, and I'm going to pick up there minus 10. By the order of operations, this is negative 2, minus 6, minus 40. Looks like maybe negative 48. Number 8 is this, something a little different. It's a function within a function. A function f on the outside and a function g on the outside. So this derivative will be the derivative of the outside, which is f prime, because f is the function on the outside. So its derivative is f prime. Repeat the inside, which is g of x, times the derivative of the inside, which is g prime. That's what we did when we did that extended power rule. Like when we had this, we dropped that power down. That's differentiating the outside function. So if I had h of g of x, what would be that derivative? It would be h prime, repeat the inside, and times it by the derivative of the inside. But I need this value at 2. So g at 2, where's that coming from? Up here. So 1 minus 4 is negative 3. It's a little different. And g prime at 2 is negative 2 times 2, which is negative 4. And f prime at negative 3 is the slope of the tangent at negative 3. So negative 3 swings me over here, and this slope is a positive value because it's going up. And in fact, it's 1. So 1 times a negative 4 is negative 4, it looks like to be. And then over here, I'll go over in the next video here, just cleaning up the derivatives. So really, in some of these here, pretty much what we did. But in number 1, I always start with the question when finding derivatives. Is it a quotient? The answer is no. Is it a product? And the answer is yes. Would I do algebra first? Yes. I would distribute adding those exponents. And 2/3 plus 2 is 8/3. And then that's x to the 2/3. And then f prime is found by dropping down that power, repeating x. And when I subtract 3 over 3, I get 5/3. Drop down that 2/3, repeat the x, and decrease it by 1. I'll go down here to number 3. F prime, its derivative is a quotient rule. Is it a product? Oh boy. Is it a quotient? Yes. Would I do algebra first or a quotient rule? Quotient rule. There's no monomial at the bottom. So it's the bottom times root of the top minus the top times root of the bottom all over the bottom squared. But this time we have to clean it up. So I'm going to distribute the 4 through, get 20 minus 12x squared. I like to just dissolve those to become a positive. So what's that going to be there? 24x squared plus 30x. And you don't have to FOIL out the bottom. We actually like it kind of factored already. If I clean this up, I get 12x squared plus 30x plus 20 all over the bottom squared. Never simplify that. The biggest one that we have to clean up is number 2. Okay? And how we clean up a derivative is either by getting a common denominator or factoring. That's how we're going to clean up derivatives, either getting a common denominator or by factoring. So this is going to produce a product rule. This is the one. Is it a quotient? No. Is it a product? Yes. Would I do algebra? No. I'm going to do a product rule. So I need some room here for this. This is going to be g prime of x equals the first times the derivative of the second. Remember 4 things. Drop down the power, repeat the inside, decrease that by 1, and times it by the derivative of the inside. That's where I run out of room here. I don't like this part. Plus the second, which is 2x plus 3 cubed. And the derivative of the first, drop down the power, repeat the inside, decrease it by 1, and times it by the derivative of the inside. So this product rule has 2 pieces. I'm going to clean this up to be 6 times 3x plus 1 squared times 2x plus 3 squared. And 3 times 2 again is 6 times 2x plus 3 cubed times 3x plus 1. So there's your derivative. But to clean this up, again, we're either going to factor or get a common denominator. Factor or a common denominator. Well, there's no fraction, guys, so there's no common denominator to get. So I'm going to try factoring out the GCF. But this time, your GCF is a binomial, and it's the lowest exponent. So I'm going to take out a 3x plus 1. In between these two, I'll take out a 2x plus 3 squared. You could have taken out the 6, but I'm not going to worry about that. So then now, this times a 6, and I think I need a 3x plus 1. Because 6 times this would give me 6. 3x plus 1 times this is 3x plus 1 squared times 2x plus 3 squared. So like when I multiply this and this right here, I'll get this right here. Plus 6 again. And I need that other factor of 2x plus 3 because I already have the 3x plus 1 taken out. So I'll clean up the inside. 18x plus 6 plus 12x plus 18. And that gives me what there, 30x plus what, 24? This is one that we have to know how to clean up. And again, it's not really hard. It's just algebra factoring. And number 4, do we have a quotient? Yes. Would I do algebra first? Yes. Why? I'm dividing by a monomial. So no quotient rule. I'm just going to subtract those exponents. But now its derivative is found by dropping down the power, repeating the x, and decreasing it by 1. And there's my derivative. And now I'm going to go into some homework problems. And I'm going to tackle probably first the newest part, which is the graph. So I'm going to do some of these. So here we got to be careful. It gets a little tricky because you're given 2 graphs. So this is G. And then this other one, which I'll trace out in blue, is F. H is this function here given. And I'm just going to say, or write out already, that H prime is 2x minus 2. All right, let's tackle these. I need to find K prime at 2. So K prime of x is F prime of x plus 3 times G prime of x minus 1/2 times H prime of x. I need this value at 2. So I'm going to be a little lazy here and just cross out all the x's and make it 2. F prime at 2 from the graph means the slope of the tangent line at 2. So when x is 2 for f, just got to make sure you see the right color here. And it definitely looks like it's blue because the G1 is here and the F1, the f of x is down here. So at 2, I'm going down 2 and right 1. So that's -2 is that slope. G prime at 2 is the one in red. So here's when x is 2, but I need to count from a nice corner to another corner. So the slope of this piece is up 1, 2, 3, right 2. So it's 3 times 3 halves. And h prime at 2, I'm going to go to my formula for h prime. And 2 times 2 is 4, minus 2 is 2. And I think I get -2 plus 9 halves, right? Minus 1. And then the rest is pretty easy. And down here for number 10, I have to do a product rule. So K prime of x equals the first times the derivative of the second plus the second times the derivative of the first. And then I'm going to replace x with -2 here. So getting a little small here. And what is f at -2? Oh, hopefully we have a nice value. We don't. Let's see here, because this is f, right? I don't want to do that in blue. That's in blue. So f at -2, I got to figure out what that line is again. So this will be on your test. You got to know how to find the equation of a line. This one's not too bad, though, because I can count up here the slope. Let's see. I see a nice one. Up 1, 2, 3, and right 1, 2, 3, 4. So the slope is 3/4, and its y-intercept is +3. So that worked out to be okay. So I'll go over that again. I need here f at -2, which is this blue line right here. And I need to figure out, that line. It's actually equation. Oh, wait a minute. No. I'm in the wrong direction here. That's G. I keep interchanging those. So F is right here. This is G. So G is, I'm good with G. I thought I was finding F first. So G of x is up 1, 2, 3, right 4. So it's 3/4 x plus 3 then, right? So that's G. F of X. Oh boy, I need this right here. Not too bad. Down 1, 2, 3. Right 1, 2, 3. Oh, wait. Down 1, 2, 3. Right 1, 2, 3. So negative 3 over 3 is negative 1. Now I need this other value, though. I need the y-intercept. So I could see it's going to be minus 1 because I have a slope of negative 1. So I think that will work. And I'm just going to double check here. Negative 4. Yes. So there's my equation. So this here is f. And this part here is g. So this is f of x. So again, just to recap what I'm doing is finding the equation of those two lines, f and g along those segments. So f at negative 2 is going to come from here. And negative times the negative 2 is 2, minus 1 is 1. And I could see here that if I didn't fill this line, this is f, and at negative 2, I do have a y value of 1. G prime at negative 2 is the slope of the line at negative 2. And again, that slope does not change along this line, so it's going to be positive 3/4. G at negative 2, got to be precise. So G at negative 2 is here. This is G. I can't read what that is, but I have its formula. So G at negative 2 equals 3/4 times negative 2 plus 3. And that reduces to negative 3 over 2 plus 3 times this by 2 over 2 to get a common denominator. 6 minus 3 is 3, so that's 3/2, right? So that's going to be positive 3/2. And that seems about right, like 1.5. So I'm pretty good with that. Times the slope of f at negative 2. So this is you have to be careful. This is g, this is f. And this slope is down 1, right 1, or negative 1. So this answer would be multiply first, times this by 2 over 2 to get a common denominator. So it looks like it'd be negative 2/4 or negative 1/2. Okay, and I'll do one more. I'm gonna do it to the tougher one here, maybe. At number 12, negative 3, that looks good. That's the same line. Okay, so the derivative would be k prime of x equals the bottom times the top, which is 2 times f prime, minus the top times the derivative of the bottom, all over the bottom what? Squared. Then I'm running out of room here. I need to replace x with negative 3 everywhere. All right, let's do this. What's g at negative 3? G at negative 3 is here. Here's g. I got the formula for g. So I'm just going to replace x with negative 3. That's negative 9/4 plus 3. So g at negative 3 is negative 9/4 plus 3. 12 minus 9, so that would give me 3/4. Times 2 times, what's the slope at negative 3? Well, the slope at negative 3 for f, I'm looking at f, and this is f, is down to right 2, so it's just negative 1. So that's all of that piece, everybody. That's this piece. Minus 2 times f at negative 3. Replace x with negative 3, and you get 2. And I could see that right from the graph, that that's 2. G prime at negative 3. Here's g, and g prime at negative 3, its slope is 3/4. All over g at negative 3 squared. So g at -3 is -9/4 plus 3 is 3/4 squared. So, man, not the nicest of answers, just a little tedious there. And number 13, its derivative, be careful, is k prime of x. This is really written as 3 times h of x to the 1/2. So it's a function within a function. It's the extended power rule. I'm going to drop down the 1/2, make it 3/2, repeat the inside, decrease the power by 1, and times it by the derivative of the inside. So that's going to come out to be 3 over 2 times the square root of h of x. Because that exponent's negative, I'm going to kick it to the bottom, push through, times h prime of x. And all I'm going to do is replace this with 3, and h prime at 3 is here. So 2 times 3 is 6, minus 2 is 4. So that's going to be 3 times 4 over, and h at 3 is here. So that's 9 minus 6 plus 3, and 3 plus 1 is 4, and the square root of 4 is 2 times this 2 is 4. And looks like my answer there, everybody, is 3. And then just back here to clean up a couple of these. In number 1, you would distribute first and use algebra. So is it a quotient? No. Is it a product? Yes. Do algebra first, and then your product rule. In number 2, I would do a quotient. Is it a quotient? Yes. You would do a quotient rule. And I'll come back and redo that one. Number 3, is it a quotient? Yes. But would you do algebra first? Yes. You would rewrite that, subtracting the exponents. In number 4, it is a quotient, but you would rewrite it first to the negative second power. Then its derivative would be -4, repeat the inside, decrease it by 1, and times it by the derivative of the inside. In number 5, is it a quotient? No. Is it a product? Yes. Do algebra first and distribute, then do your power rule. Number 6, is it a quotient? No. Is it a product? Yes. Do a product rule, and I'll come back to that one. Number 7, is it a quotient? Yes. You would not do algebra first. You would just do a quotient rule because you're not dividing by a monomial. And last but not least is number 8. Is it a quotient? No. But is it a product? Yes. You would not do algebra. You would do a product rule. So I'll clean up either numbers 6 or 8. So the ones you have to clean up is one like number 2. F prime at t is the bottom times the derivative of the top, which is 6t, minus the top times the derivative of the bottom, all over the bottom squared. And then that becomes 30t minus 24t squared. These just become a positive 12t squared plus 20, all over the bottom squared. And I think that's pretty easy to go from there. But these are the two. I think that's pretty easy to clean up. You just distribute on both sides and then combine like terms. But in 6 or 8 is the one you have to be careful about. So let me tackle number 8, where you have to clean it up. Okay, so this is a product rule. So it's going to be the first, which is this, times the derivative of the second, which is drop down the power, repeat the inside, decrease it by 1, and times it by the derivative of the inside. Plus the second times the derivative of the first, which is 4, times 3 minus 2x cubed times -2. Okay, so that's my derivative. Remember, anytime you drop down that power, repeat the inside, decrease it by 1, and times it by the derivative of the inside. And now this is going to be slightly cleaned up. And what's 4 times -2? -8. And remember, to clean up any derivative, you're either factoring or getting a common denominator. So what I'm going to do in this one is factor. So I'm going to take out, between this and this, I'll take out the lowest. Between this and this, I'll take out the lowest exponent. And what's left is 15 times a factor of 3 minus 2x. So then I multiply these, I get that to the fourth power. Minus 8 times 3 minus 2x. Okay, because then this times this will give me to that. Oh, wait. No, it's 2 plus 5x. Yeah, see? Good thing I double checked my work. So then now this factor times this will give me all of that back. The only thing you're left to do is distribute on the inside. 45 minus 30x minus 16 minus 40x. And then just combine like terms. What would that be then? 5x. Well, not exactly here. Boy, I can't see here. So minus 16. So this is minus 70x then. And then minus, what is that? 29. So again, the name of the game is factoring. And down here, again, got a little, not hard, but just a little tedious, but we have to get used to that. Here we had to, recognize that this is F, this is G, and you need to find the equations of those lines in order to retrieve those Y values. The slopes are easy to calculate because it's just you're counting up and down or right and left. Yeah. Okay, so that's all of the homework as well as the lesson on that.